problem is asking us to find the values of the variable for which the rational expression is undefined. And I'm getting 5p over p minus 1. Obviously, the only thing I have to write is that p minus 1 is not equal 0, or p does not equal 1. That's all. Let me know if you have any questions. Please stop me if you have any questions. On question 2, we're asked to simplify, so I have 5x plus 20 over x squared minus 16. Although this is not necessary here, it's extremely important to realize that everything has to be fully factored, and this is the difference of squares. We've seen that so many times. This is not something you have place to put in, but please remember, it makes no sense if you don't understand the situation. So 5 over x minus 4, this is the correct answer. Stop me, please, if you have questions, please. Okay, the next question. W minus 4 divided by 3w minus 12 and divided by 11w over 3. I wasn't sure why this creates a problem, but maybe you can tell me why. So w minus 4 has to stay as w minus 4. There is nothing I can do to it. But the denominator is 3w minus 4. And then I flip this because I have to multiply by 3 over 11w. I will have to state that the w cannot be 0 and w cannot be 4 from here. I can simplify the function, the fraction by itself. And now because I changed it into a product, I can also simplify across. So I have 1 divided by 11w. If it's 11w is the denominator, you cannot write that this is 11w. That would be incorrect. You cannot move it. It has positive power. You have no right to move it anywhere else. It is in the denominator. It has to stay in the denominator. That's why I put these ones, so nobody gets confused. There is only 1 in the numerator and 11w in the denominator. Okay, any questions? Okay, the next one. Here we are asked to solve the inequality. So this is x over 2 greater than or equal to 1 minus x over 4. All I have to do is find the least common denominator and multiply and clear fractions. That's the first thought ever. Clear fractions, clear decimal numbers, clear fractions. And the least common denominator is 4, so then I will multiply everything by 4. This by 4 gives me 2x. This by 4 gives me 4. And this by 4 gives me negative x. I do not switch the inequality symbol because I multiplied by a positive number. It has to stay the same. Of course, I have to bring x to this side, so I have 3x greater or equal to 4. And now I have to divide by 3. So x greater than or equal to 4/3. So if I'm asked to graph it, 4/3 is somewhere here with the full point and to the right, or the bracket and to the right. So the interval notation will be 4/3, comma, infinity. Is this okay? Okay, problem 5. So choose the correct map. So I see -5, -1, 0, 1, 2, and 5. This is it. -5, 5, -1, 1, and 0. And let's see if they go to correct numbers. -5 and 5, they go to 10. 2 comes from -1 and 1 to 2, correct, and 0, 0. So this is it. What will I write as a domain? Exactly what I see here. -5, -1, 0, 1, and 5. Just list them with a comma. What will I write for the range? Just what I see, 0, 2, and 10. in ascending order. That's it. Here, we did this problem together. The domain is -5, -3, 0, 4, and 5. Again, -5, -3, 0, 4, and 5. What is the range? -5, -4, +3, +5. And you just have to list them with a comma, and that's it. Find the values. So I'm given 0. 2 times 0 plus 1 is 1. I'm given 3. 2 times 3 is 6. 6 plus 1 is 7. -4 times 2 is -8. -8 plus 1 is -7. You can say I'm in a test situation. I want even to do this problem even faster. Fine. You go to the graphing calculator and you punch in y equals. And you do not have y in the calculator, but it doesn't matter. I have 2x plus 1. And then second and table. And I punch in the numbers I'm given, 0, 3, and -4. Quickly. 0, 3, -4. And I'm done. 1, 7, -7. And I enter them. 1, 7, -7. 8. The square root of 1 is 1. With minus in front would be -1. And that's it. The square root of a negative number is not a real number. Again, why are they asking the same thing twice? Don't ask me. I have no idea. That's all I need to write. Here, if you forget the absolute value, that is wrong, because it does not say anything about the variable. Whenever it does not say anything about the variable and it is an even root, which is 2 squared, I have to write, you cannot touch anything inside because we are dividing the power by the index. But you have to put the absolute value because x plus 25 can be negative. Here, or state, select the, type an integer or a simplified fraction. So the square root of 25 is 5, the square root of 9 is 3, 5 plus 3 is 8. And that's it. Write the expression as a radical, and this is power 1/2. We have to remember forever this is the radical, which is the square root. All I have to write is, it says simplify your answer, so I have to write 2. Because this is the square root of 4. Remember, we have to be able to go back and forth from rational exponents to radicals. So if I have the square root of x to the 5th, then this is nothing else but x to 5 over 2. If I'm given 6 to 1/2, this is the square root of 6. We have to be able to toggle between these two very quickly. Let's say 27 to 1/3. I have to know that this is the cube root of 27, which is 3. So going back and forth from an exponential notation that has a fractional exponent back to a radical, and from a radical back to this. This is just a single formula. It's not some, I know if you look at all of them, yes, it's a big deal. Okay, rewrite this with positive exponents. And we know how to do this. This is 1 over 1024 to -2/5. If an expression has a negative exponent and it's found in a denominator, we'll move it to the top with a positive exponent. If they want us to simplify, we need to remember that this is the 5th root of 1024 squared. You do not have to calculate anything because the calculator will do it for you. So you just simply put 1024, put the caret, and in parentheses, exactly what we have, 2/5. and you get the answer. And you just enter 16. Select the correct choice, and so on and so forth. So this is just 16. Okay, moving on. Here, some of you forgot to copy the base. So the rule is 6 to 5 fourth, 6 to 1 fourth. You must remember what I say all the time. I know I sound like a broken record. You have to copy the base and subtract the exponents. 5 over 4 minus 1 over 4 is 4 over 4, which is 1. But you cannot write 1. Many of you wrote 1. But they are not the same. The answer is 1 only if they are the same. X over x is 1, assuming x is not 0. 2 over 2 is 1. But here is not. These are not the same. You can never write 1. So what I'm saying is you forgot to write the base. So when we use an exponential notation, we first copy the base, and then in this situation, we subtract the exponents. From the exponent of the numerator, we subtract the exponent of the denominator. Good. Okay, many of you forgot something very important. So this is an example. I'm going to come back to it in a second. I just wanted to say this. If you had 3x to the 4th power, you wrote 3x to the 4th power. What's wrong with this? What's wrong with this? Can anyone tell us what is wrong with it?
You can take the 4th power to the 3.
Absolutely. It's 3 to the 4th, which is 81x to the 4th. Thank you. Absolutely. So then coming back here to our example. First, if you remember, we said let's address the negative exponent. We don't want negative exponents. So I'm going to jump over what my explanation here. So follow the triangle. So I first write 1 over 3 times 64 to 1 over 9 and everything to the 3rd. And now I apply this rule. What rule? I still have 1 over, but 3 to the 3rd. You can write 27 or just write 3 to the 3rd first. Copy the base. Now the rule states to multiply the exponents. 1 over 9 times 3 over 1. We never multiply if we can simplify first. So this is power 1/3 on the 64. But this is the cube root. And I know the cube root of 64, you can calculate it, it's 4. Or you can use the calculator. So all I have to do is write 1 over and multiply these two. 108. This problem requires several steps. I give you that. First, you must address the negative exponent first. Then, you cannot forget that once we have parentheses, every factor, they're factors because they're multiplied, terms are added and subtracted. Every factor has to be raised to this power. I raise the first factor, I get 27. I raise the second factor, and I get 64 to 1/3. Now, what is 64 to 1/3? Well, this is the cube root of 64, which is 4. I have to multiply it by 27, and you cannot move this to anywhere, to the top or something. No, because everything here has power 1. You have no right to move it to the top because it has a positive power. It has to stay where it belongs. Any questions, please? Okay, use the product property to multiply. This is a straightforward situation. But what we need to do is just be careful and see if we can simplify in any way. I won't be able to because this is 2 and 11, right? So I have to write everything under the same umbrella because they have the same index. Otherwise, I cannot do this. But they do have the same index. And 11 times 11 is 121. And times 2 is 242. And this is it. Because I have an 11, a 2, and an 11, there is, and the cube root, I cannot simplify. This is it. All I have to write is the cube root of 242. (17). The same thing here. We are using the same property. So 5x divided by 9 times the square root of 9 over x. We are using the same umbrella. Why? Because they have the same index. So I will write 5x over 9 times 9 over x. I will refuse to multiply. I will always refuse to multiply if I can simplify first. And this is it. It's just a blink. Any questions so far? Okay, 18. Okay, here we have to be careful a little bit because we have to split the radical first. So the cube root of negative 64 times a to the third. Split the radical first. I recommend that. Notice that it's the cube root. So this is just a, 3 over 3. We already talked about this. This is negative 4. So the answer is negative 4a. Because negative 4 to the third power is negative 64, and a to the third power is a to the third power is a to the third. And that's it. Again, very simple, I think. (19). Evaluate. Okay, you can say I'm in a test situation. Fine. I'm going to use the graphing calculator. I'm going to put it in y equals. I'm going to delete everything. I have the cube root of z plus 10. I remember, parentheses, there is no x. So this is z plus 10, caret. I know the cube root is power 1/3. And that's it. And I plug in the numbers. What are they giving me? 54, negative 74. So 54, negative 74. And I think the last one is 256. Is it? I'm sorry. I don't know why I got negative 138. Okay, negative 138. Okay. So I have 4, negative 4, and negative 5.04. Just plug them in, and you're done. 20. Find the domain. We have always to remember, we have to remember that any even index requires positive or 0. So then f of x, which is the square root of x plus 1, this quantity, which is this quantity now, must be greater than or equal to 0, which means this. And the domain is negative 1 to infinity. That's it. 21. The graph, we graphed these. If you remember, you told me how to graph them. But we have to remember those. There are a few graphs that I taught you that you have to remember forever. So this is the graph of the square root of x. Very nice. It's not a straight line. It's only in the first quadrant and from 0 like this. So this is the square root of x. And they're asking us to graph the square root of x pulled down 6 units. This is not the square root of x pulled down 6 units. This is not the square root of x pulled down 6 units. This is not the square root of x pulled down 6 units. That's it. What will be the range? So first of all, the domain. Of course, we know the domain is from 0 to infinity. We just wrote it. So greater than or equal to 0. That's the domain. And what is the range? Well, we are pulling down this 6 units. So if I'm pulling it down 6 units, the graph looks like this. So obviously it starts at -6 and it goes to infinity. So then the range is from -6 to infinity. Because the graph is pulled down 6 units. 22. Nobody says anything, so I don't know. Are you okay? Is everyone okay? Okay, let me stop this video.